In today's lesson, we're going to convert between degrees, minutes, and seconds and decimal degrees. We will then convert from decimal degrees back to degrees, minutes, and seconds. We will look at the conversion between decimal degrees and radians and decimal degrees. When we look at degrees, minutes, and seconds, there's two things we need to know before we can start. The first one is that the conversion between seconds and minutes is the same for angular measurement as it is for time measurement. And so the factor of 60 seconds for every minute, it's the same between minutes and degrees as it is between minutes and hours, and so again it's another factor of 60. The other thing to think about is that when we see an angular specification of degrees, minutes, and seconds, we actually are talking about moving so many degrees plus so many minutes plus so many seconds. So when we do our conversion, we will be able to add the numbers we get together. First thing I want to show you is the roll-up method. And the roll-up method is going to take us through the process of converting the seconds into minutes and then the minutes into degrees. And so in this case, I have 36 seconds. I am going to multiply it times a unity factor of 1 minute per 60 seconds. My seconds cancel out. I'm going to be left with units of minutes, and my answer is 0.6 minutes. I can now rewrite this as 30 degrees plus 18.6 minutes. I now want to roll up those minutes into degrees, and so I'm taking 18.6 minutes times a unity factor of 1 degree per 60 minutes, and my answer comes out to 0.31 degrees. Now adding that together with my 30 degrees gives me 30.31 degrees as my final conversion from degrees, minutes, and seconds. I like to show a second method here, which I'll call the all-in-one method. And this method takes us from degrees, minutes, and seconds directly to degrees. And so once again, I'm going to consider these to be added together. If I have 36 seconds, I know that that divided by 3600 will give me straight conversion to degrees. From 18 minutes divided by 60 will give me straight conversion to degrees. And so if I do the arithmetic, I wind up with numbers that look like 30 degrees plus 0.3 degrees plus 0.01 degrees. And I once again get the answer of 30.31 degrees. And so depending on how your brain works, you may find one of those methods easier than the other. When I'm converting between decimal degrees and degrees, minutes, and seconds, I find that the roll down method is the one that makes the most sense. And so I'm going to divide this up into 42 degrees plus 0.7372 degrees. And now I'm going to roll that into minutes. And so 0.7372 degrees times 60 minutes for 1 degree. Degrees cancel out. I am left with 44.232 minutes. My angle now looks like 42 degrees. 44.232 minutes. Now I want to roll those decimal minutes into seconds, and so I'm going to take just that portion, 0.232 minutes. I'm going to multiply by 60 seconds per 1 minute, and I come out with 13.92, which for our purposes is 14 seconds. And so my conversion then takes me to 42 degrees, 44 minutes, 14 seconds. Now let's go between decimal degrees and radians. In order to go between decimal degrees and radians, we need to remember that 2 pi radians is 1 full circle is equal to 360 degrees. And so that's how we're going to build our unity factor. We're going to take 238.42 degrees. We are going to multiply by the ratio of 2 pi radians per 360 degrees, which takes us to an answer of 4.1612 radians. To convert from radians back to degrees, we still are using the same relationship of 2 pi radians equals 360 degrees. But in this case, we are going to invert that when we do it. And so we are going 0.251 radians times 360 degrees per 2 pi radians. And when I do that calculation, the answer comes out to be 14.38 degrees. The important thing to notice here is that a quarter of a radian, 0.251 radians, is still 14.38 degrees. And if we are going to have any level of precision when we work with radian measure, we need to carry a minimum of 3 or 4 decimal places in order to make sure that when we convert to degrees, we get something which is reasonably accurate. And so there's your conversion from degrees, minutes, and seconds to decimal degrees and on to radians.